Hi everyone, I hope you are doing well. So in this video, we are going to discuss Leetcode problem of the day, and today's problem is cherry pickup 2 and it is a hard level problem. So the problem basically says that we have been given a two-dimensional grid with certain number of rows and columns. Those are not necessary to be same. That means the number of rows and number of columns can be different. Now we are given that the first robot is located at 0, 0 and the second robot is located at 0, columns -1. So basically the first robot is on the top left and the second robot is on the top right. Now they can move either down left or down right. You can see by these arrows they have three positions to move, and they are eventually going to reach this last row. That is when the game will end, or that is when you have to finish your task. Now during their journey, both of them want to pick the maximum number of coins, and we have to find the total maximum number of coins both robots can pick together. The only constraint is that when they land on the same cell, right, when they land on the same cell, it will only be given to one of the robots, and when a robot has picked one of the cherries or whatever you say, right, that particular thing cannot be picked by any other robot, right. So let me just take this as an example. So as you can see, we have this particular thing here. This is the whole cell. Now if you talk about the first robot, it can move one step downwards, then it moves one step right, and then it moves one step left, right. These green cells are the cells traversed by robot 1, and these blue cells are the cells traversed by robot 2. It moves left first, then right, and then down, right. So there are two conditions: that if a robot, let's say, has picked this particular cell or the cherry on this particular cell, then it will be marked as taken, right, and then this particular robot cannot pick this one. And if they both land at the same site at the exact same time, then it means it will only be given to one of the robots. This way we have to try to maximize total cherries or the total value that we get, right. This is our whole question. So how can we actually solve this? We are going to try to solve this problem with dp. So let me define the dp states first. So I'm going to have a three-dimensional dpi, and let's say x and y, right. So I is going to denote my current row, x is going to denote the column of robot 1 in current row. Similarly, y is going to denote the column of R2 in current row, right. So here we have three things where I is denoting the current row, x is denoting the position of this robot 1 in the current row, and y is denoting the position or the column of robot 2 in the current row. So what are dp of I, x and y going to denote together? This is going to denote my best answer if I start from ith row and robot 1 is at x and robot 2 is at y, right. So basically dp of ixy is going to denote my best answer if I start from the ith row and my robot 1 is at column x and robot 2 is at column y. So naturally you would think that the final answer is going to be stored in dp of 0, 0, m minus 1, where m is, let's say, the number of columns, right. So this is 0, the first 0 is because of the number of rows, the second 0, here we had 0, then m minus 1, right. So the second 0 is because this robot 1 is at column 0, and this m minus 1 is because the second robot is at column m minus 1. So here our final answer will be stored. Now let us discuss where will the thing end. So dp of base cases, where this will be when I is equals to n minus 1, that means we are at the last row. So let us see how we can try to solve this particular problem. So I'm just going to write the helper function first, and then we'll discuss how can we convert this particular code into iterative form, right. So let's say I have int I I, X and Y. So these are the three things that I am going to receive, right? So if I is equals to n minus 1, I am just going to write the base case first, right? If I have reached the last row, what I am going to do, if X is equals to Y, return grid of Ix, otherwise return grid of Ix plus grid of Iy, right? So I have written this particular thing here. Let me explain you what is happening. I have written a base case when I reach the last row, that is this one, right? So what happens when both X and Y, that means both robot 1 and robot 2 are at the same cell? They're going to get this value only a single time. What happens when they are at different cells, robot 1 here and robot 2 here? They're going to get a sum of these values, 2 plus 1, that is 3, right? So this is how the base case is formed, right? This is very simple. Now if dp of Ixy is not equals to minus 1, that means it has already been calculated. So I'm just going to return dp of Ixy, right? This is also very simple. Now I know that I am at the ith row and the next positions are X and Y, right? So robot 1 is present here X and robot 2 is present here Y. Now I am going to find the next positions. So what can be the next positions? I plus 1 is going to be there, that is for sure, because we are going to move on to the next row. What about the columns? The columns can range from minus 1 and then 0 and then 1. So what are these three values? That means my column can decrement by 1, my column can remain same, or my column can increment by 1. These are the only three possible operations that we have. Similarly, for robot 2 as well, the column can decrement by 1 and it may remain same and it may increment by 1, right? And these two events are independent of each other. So if the first robot has 3 ways, the second robot has 3 ways, and those events are independent like this, so the total number of ways will be 9, right? So what I am going to do, let's say I am going to form two for loops. Int p1 is equals to minus 1 and p1 should be less than 2, and I should do p1 plus plus. So basically p1 will be from the range minus 1, 0 and then 1. Then I have int p2 is equals to minus 1, p2 is less than 2 and p2 plus plus, right? Now what I'm going to have here is, let me just close these brackets. Now I have p1 and p2. p1 and p2 are themselves going to denote the change in the column for robot 1 and robot 2 respectively. So if I change these columns, then x plus p1 is going to denote the new column for robot 1. Now it should lie inside the grid, so I must have these conditions checked, that x plus p1 should be greater than minus 1 and x plus p1 should be less than m. Similarly for p2 as well, and y plus p1 is greater than minus 1 and y plus p2 should be less than m. So this is also p2, y plus p2, right? So with these four conditions, I have made sure that the new coordinates of these robots are valid coordinates and they are not falling out of the grids, right? Once I know this, I am going to find my current answer as grid of I, X and Y, right? So if X is not equals to Y, what I am going to do, I am going to set my current answer as plus is equals to grid of I. So this is actually Ix only, and this is grid of Iy. So basically what I am doing is, I am trying to find what is my current answer. So if they are currently at positions X and Y, my current answer should be grid of Ix. Now if X is not equals to Y, I also have to add the value for the second robot. If X equals to Y, that means they both are at the same coordinate and I don't need to add it again. But if they are different, I need to add the value for the second robot as well. Now once I have added this particular value, what I need to do is, I need to find the answer that they will produce by going on to the next value, next index. So this is going to be dp of I plus 1, or let's say helper of I plus 1, comma, my x plus p1 and y plus p2. So you see what is happening here. So let me just first complete the code, then we will discuss it. So here I'll have to include dp of xy is equals to 0 and dp of Ixy is equals to maximum of dp of Ixy comma current answer. So you see what happened here. First of all, I am trying to I know that I am at currently position IX and IY. IX is the position of robot 1 and IY is the position of robot 2. Once I know this, I am trying to figure out what are the positions they can go to. So for the first robot I have P1, for the second robot I have P2. The second thing is I made sure that these P1 and P2, X plus P1 which is the new Y coordinate for the robot 1 and Y plus P2 which is the new Y coordinate for robot 2 are inside the grid. So this should also be X plus P1 here, right? And now what I do, once I verified that they lie inside the grid, I initialize my current answer with grid of Ix. Now if X is not equals to Y, that means the robots are currently at different positions. I also need to add the second robot's value, that is grid of Iy. So current answer plus is equals to grid of Iy. Now I'm going to update my current answer with what value? I'm going to move on to the next row. So the next row is at I plus 1. When I move on to the next row, the new y coordinate for robot 1 will be x plus p1 and the new y coordinate for robot 2 will be y plus p2, right? Once I know this, I'm going to set my dp of ixy as maximum of dp of ixy comma current answer, because there are 9 total different ways from the same x and y to go into the next row. That is why I have to go through all those 9 different ways and then figure out the best among them. And at the end I can just return dp of ixy. This would be the final solution of this particular problem. Now you can try to write the same code iteratively as well, and I believe like this might look a little bit complex here, but if you try to understand it very slowly, it will be very helpful for you. It's nothing, I'm just trying to explore all the different parts from one particular cell, right? So now as you can see, what I've done here is, this is the same code just written iteratively. You can clearly see that this particular part is the same as that I have written here, right? And also one more thing, I believe I have not explained it in that particular solution. So we have some constraints here, right? Although it doesn't really matter, if even if you remove this, it will still work. So let me remove it and then let us just try. So I'm just going to close this and then have it here. So if it works without it also, then there is no need of explaining those things. So I'm just running it first so that we can make sure that this solution is correct, and it means also submit this. So you see, this basically passes all the test cases, and this solution is correct. If you didn't see it, yeah. So you can see this is passing and getting accepted. Now let me explain you what I did here. You can clearly see that this is the same logic that I have written here, exactly the same logic here, right? Now you can also compare it by pausing the video. So I'm not going to explain this logic right here. I'm going to explain these for loops only, right? So before those for loops, I've initialized these n and m as the size or the dimensions of the grid, and I've initialized my dp array with n, that is the number of rows, and m cross m, which can be the valid column positions of each of these robots. Now you can clearly see that every time my dp of current row was depending upon dp of the next row. So that is why I have to make this for loop in reverse order for the number of rows. Now x and y are, since the first row has been sorted, then these x and y, the order doesn't really matter. I can take any order of x and y, right? And this part is very straightforward that I've already explained, so not going to explain it again. And at the end, what I just do is I just return dp of 0 0 my m minus 1. We've already discussed why we return this, because my answer or my initial state is going to be the 0th row. My robot 1 is at the 0th column and my robot 2 is the m minus 1th column, right? So this is going to be my final answer. I've already submitted and shown you that this particular code works. So I hope that you guys were able to understand the solution. If you guys did, consider dropping a like on this video. Don't forget to share thoughts in the comments, because your engagement with this video really helps the YouTube algorithm to understand that this video is actually helpful for you, and it will be able to reach much more people like you who want to keep solving new problems. So that is it for today. Till the next video drops, keep coding, stay safe, bye bye.